So the first thing that your report needs is a title, and the title should give the reader some idea as to what to expect when they read through your prac report. What are you discovering? What are you investigating? What are the key things in your report? So that if people wanted to search for it on Google or through some sort of database, they could search for keywords and it'll come up in your title. So it needs to be something that summarizes your whole report in just a handful of words. Usually about 6 to 8 words is fine. In this particular example, we're going to have 2 balloons, and one of these balloons is going to go into the fridge where we expect it to contract or shrink because of the cold air. And so an appropriate title for this particular experiment could be something along the lines of an investigation of the relationship between cold air and contraction. In most scientific experiments, there has to be some sort of purpose or goal behind it, and we call this our aim. In this case, the aim is to examine the effect of air temperature on the size of a balloon. Next up, we have our hypothesis. And the hypothesis is an educated guess about what you think will happen in this experiment. So I use the word educated because hopefully you've learnt something about some aspects of this experiment in class already. So for example, in this experiment, you might have learnt that heating things up expands things and cooling things down contracts things. So we're going to use that information to create our hypothesis. In this case, that could go something like the balloon that's at room temperature, which we call the control, will stay the same, while the balloon that's cooled down will contract. A control in any experiment is basically something that stays the same. It provides a baseline to compare your results to. Now we're going into what's called the method part of the report, and we're going to start by listing the materials that we'll need. So you want to be really specific in this part of the report, especially when it comes to using different sizes of things. So if you're using different sized beakers, actually specify what size of beaker it is, whether it's a 500ml beaker or a 250ml beaker. If you're using different weights of things, say how heavy it is, whether it's a 2 kilogram weight or a 5 kilogram weight, and also list the quantities of things as well. In your procedure section, you basically write a step-by-step recipe that uses all of the materials that you've mentioned in the materials section so that anyone can pick up your report and replicate your experiment perfectly without having seen it before. In this example, we'll measure the circumferences of each of the balloons and we'll put one of them in the fridge. And after 24 hours, we'll take it out of the fridge, we'll measure the circumferences again, and we can compare whether the one that was in the fridge has shrunk in size any more than what it would normally shrink anyway. There are a couple of ways that you can represent your results in your results section. You can have qualitative data, which is when you're using words to describe what happened, like the color of something, how something looks or sounds or feels. You can also have quantitative data, which is using numbers and units of measurement like seconds, kilograms, centimeters, and you can then use that data to create graphs and tables. So qualitative data is describing what happened using words and sentences, and quantitative data is representing your results as numbers. Because I've measured the sizes of the balloons and I'm representing that as a percentage to allow comparison between the 2 balloons, I'm using quantitative data. I could simply describe the balloons and say that the one in the fridge is a lot smaller than the one that wasn't in the fridge, but that's nowhere near as precise as actually being able to use measurements to compare the 2 sizes. In your discussion section, guess what? You discuss your results. You try and link the theories and the concepts you've learnt in class to explain what you observed in your experiment. And in high school, that usually involves answering questions that are designed to get you thinking about this structure and to get you linking the concepts in class with what you've observed. This varies from teacher to teacher, but sometimes in your discussion you can talk about the limitations in your experiment. So what are some things that might have affected your results and how could you overcome those in the future? You may also want to discuss some ways you can improve the experiment as a whole. So how could you do things more efficiently, or how could you do things differently or use different equipment to try and get more accurate results? Lastly, we have our conclusion. And with my students, I generally expect them to restate what the aim was and say whether that was achieved and why, and also restate what their hypothesis was, what they expected to happen, and whether that actually happened and why. And sometimes only part of the hypothesis is supported. And so then you can say the hypothesis, which was blah, 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 was partially supported, and then you would go on to elaborate why that's the case. You can also try and come up with implications of your findings. So try and link your results with the real world, and why is this information that we've learnt through this experiment useful to us in a real life scenario. So that's it. We've gone through the main sections of a scientific report: the title, aim, hypothesis, materials, procedure, results, discussion, and conclusion. This is usually what I expect from my students at my school, and this video is really just designed to give you an overall guide. Your teacher might have a slightly different way of doing things, and that's fine, but just double check a few things with them if you're not sure. Thanks for watching, and I'll see you next time.